Hello there, everybody, once again, and welcome back. Today, we are looking at a question from IB Physics, May of 2025, HL Time Zone 1. And this question is from Unit B.4, Paper 2. So, a system consists of 10 distinguishable particles which can exchange energy in integer multiples of a constant value E. The total energy of the system is 10E. All right. The diagram shows two possible configurations of the system. Configuration A with all the particles having same energy E, and in configuration B the particles have a range of energy from 0 to 4E. All right. When the energy of any particle in the system changes, a new microstate is formed. Cool. That is an important piece of information. This is what we are going to use when we are going to answer the next part. Outline which of the two configurations has a greater number of microstates. Now, imagine this: you've got like 10 variables and they all have to add up to 10 and they all have to be equal. That's possible only if individual individual variables have a value 1. That is what configuration A is. And in how many ways can this be done, or in how many ways can this be possible? Exactly 1. Every single variable has got value of 1 and they all add up to 10, right? Now, when you move to configuration B, you can see that the energies of the particles are 4E, 3E, 2E, and E. And then that's first 4 particles, and the remaining 6 particles have an energy of 0. Now, interesting part is if I were to, let's say, swap this, and let's say we swap these 2 particles. All right. The 2 particles are different. As mentioned in the problem initially, 10 distinguishable particles, which means every particle is different. So when you move the particles around, the overall energy will still stay the same, which is bound to be 10E. But the individual energy of the system changed, particles changed, so that resulted in a new microstate, which means there are more than one way in which this configuration can be achieved, keeping the total energy of the system 10E, but still having a newer microstate. Every time you can move particles around, and there are like multiple ways. We don't really have to count them, but just indicating that configuration B has got more than one way to exist will suffice. So based on that, which configuration has got greater number of microstates? That's B. You'll have to indicate why B, because configuration A can have only one. This arrangement can exist in only one way, but B can exist in more than one way. Easy? Not that easy, I know. Like, this question came out of the blues. Like, this was a newer addition to the syllabus, so students struggled with this one, not gonna lie. Okay, the system of 10 particles is isolated. All right. The two processes are considered for the overall evolution of the system. Process 1, initially configuration A, and then going to B, and process 2, configuration B, and then evolving into A. Explain why process 1 is more likely to occur. So for this part, we will have to go to the formula of entropy. If you recall, entropy is given by S equals to KB ln omega. Omega here represents the number of microstates in a configuration. Now, if you think about it, configuration A has certain number of microstates. Configuration B also has certain number of microstates. It's just that B has got more number of microstates. So I can write the entropy expression for both the configurations. SA equals to Boltzmann constant times natural log of number of microstates in A, and SB equals to Boltzmann constant times natural log of omega B, number of microstates in B. Now, if I look at process 1, system evolves from A to B. Now, it's an isolated system, and we know that entropy of an isolated system never decreases. So process 1, we are going from lower entropy to higher entropy. This becomes a more likely process to take place. But for process 2, we are going from B to A. B to A implies the entropy is decreasing. This is less likely to happen, right? So that's your answer to part B, because entropy will increase. So we will see the system evolve from lower entropy to higher entropy, as a result of which configuration A to B that evolution or that process is more favorable. As simple as that. So I hope you guys understood this pretty well. If you've got any doubts, do let me know in the comments. Thank you for joining, and I'll see you in the next one. Goodbye.